Hello, Year 9. This is the second lesson on scientific notation, and today we are focusing on very small numbers. Now, as we have seen from the previous lesson, our understanding of index laws, how to multiply by powers of 10 and decimals are quite relevant in helping us understand the lesson. Our intention is to express decimal form in scientific notation and vice versa, and that will be our success criteria as well. And as I said, the focus of today's lesson is dealing with very small numbers. So let's build our understanding of scientific notation with regards to small numbers. So if I have 0.000298, now I would attempt to shift the decimal point 1, 2, 3, 4 to between the 2 and the 9. So if I write this number as 2.98, then I got to divide that by 10,000 because I shift the decimal point 4 places. And this is the same as 2.98 over 10 to the power of 4. And 2.98 divided by 10 to the power of 4 is the same as 2.98 multiplied by 10 to the power minus 4, because we know from index laws that if I have 1 divided by a to the power of m, then this is the same as a to the power of minus m. We established this when we were discussing index laws. So that's precisely what we are using here. Let's look at the next example. To write this number in scientific notation, I have to attempt to move this decimal point 1, 2, 3, 4, 5, and 6. 6. So I'll write this as 4.621 divided by 1 with 6 zeros, 1, 2, 3, 4, 5, 6. But another way of writing this is 4.621 divided by 10 to the power of 6. Because since there are 6 zeros, that's 10 multiplying itself 6 times. And if you write it that way, and if you apply this understanding, then we can write this as 4.621 multiplied by 10 to the power minus 6. Right. Just look at it carefully and see the relationship between what we did in index laws and this one. And of course, we know that the power will be negative because we're dealing with very, very small numbers. And if you were to work from scientific notation back to standard form, you know that you're moving the decimal point as many places to the left as you have done power. So minus 4 means move the point 4 places to the left. Minus 6 means move the point 6 places to the left. Right, final one. 1, 2, 3. Have to move the point 3 places so that it's between the 3 and the 0. So I'll write this as 3.082 divided by 1,000. 1 with 3 zeros, because I have to move 1, 2, 3. which is the same as 3.082 all over 10 to the power of 3. So this in scientific notation is simply 3.082 multiplied by 10 to the power of 3. 10 to the power of minus 3. Beg your pardon. 10 to the power of minus 3. 10 to the power of minus 3, because it was divided by 10 to the power of 3. Okay. So now that we've developed that, let's continue developing our understanding. When multiplying by a power with a negative index, move the decimal point to the left by the same number of places as the value of the index after the negative sign. This makes the number smaller. Zeros are inserted in places not filled by other digits. We'll see soon. Multiplying by a negative number is the same as dividing by the reciprocal power. So, as we can see, 6.5 times 10 to the power minus 4 is the same as 6.5 divided by 10 to the power 4. That's what we've shown in the previous slide. And that's what you get. Because when you have 6.5 and you are dividing by 10,000, which is 4 zeros, you move the decimal point 1, 2, 3, and 4, and your decimal point will be there. Since there's no zero here, nothing there, you put a 0 there. No digit here, we put a 0 there. No digit there, you put 0 there. So you have 0.00065. But in mathematics, you cannot start with a point. So we have to put a 0 in front. And that becomes your final answer, as you see there. Remember, the point finishes there, but you have to start with something. In mathematics, that's what you do. You can't start with just a point. And so because there is nothing, that's why we stick another 0 there. Okay, so scientific notation dealing with small numbers. Again, we write it in the form a times 10 to the power of m, where the a is either equal to 1 or less than 10. It includes 1, it does not include 10. It cannot be 10. It should be a single digit between 1 and less than 10, and m is an integer. So for 417 nanoseconds, now 417 nanoseconds is 417 times 10 to the power minus 9. Now, if you want to write this in scientific notation, you have to be very careful, because in scientific notation, you see this is more than 1, more than 10. It's 417. So you want your A to be between 1 and less than 10. So you can write this in the basic numeral first. This in the basic numeral is simply 417 to the power of 9 is the same as 417 divided by 10 to the power of 9. So 417, the point is here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So the point is now here. So I add a 0, a 0, a 0, a 0, a 0, and a 0. 1, 2, 3, 4, 5, 6 zeros, 417. 1, 2, 3, 4, 5, 6 zeros, and that's why it's written like that. So 417 nanoseconds is the same as 0 point with those 6 zeros, 3, 6 zeros, 417 seconds. All right. Now that you've written this number like so, 0 point, remember we can't start with the point here, so we have to put a 0 in front. 1, 2, 3, 4, 5, 6, 4, 1, 7. Now, to now write this in scientific notation, 1, 2, 3, 4, 5, 6, 7, to place the point between 4 and 1. So that would be 4.17, and multiply this by 10 to the power minus 7, because we had to move that 7 times. 1, 2, 3, 4, 5, 6, 7. So minus 7. So 417 times 10 to the power minus 9 in scientific notation is 4.17 times 10 to the power minus 7. Be very careful when you do these things. Take your time. So first and foremost, I took that, I wrote it back in the basic numeral form, and then moved back to scientific notation. In future, once you can do this very, very well, there's a simpler way of doing it. There's a simpler way of doing it. You can simply say 417 times 10 to the power minus 9 is equal to 4.17 times 10 square, because 4.17 times 10 square will give you 4.417, then times 10 minus 9. So that's 4 equal to 4.17 times 10 to the power 2 minus 9. And that is equal to 4.17 times 10 to the power minus 7, because 2 minus 9 is minus 7. That's an easier way if you still remember what we did with indexed numbers. So you can either do that as method 1 or do that as method 2. So that's your method 1 and that's your method 2, whichever one you feel comfortable with. Right. Now let's focus on our success criteria, which is converting decimal form to scientific notation and vice versa. In this case, we are moving from decimal form to scientific notation. So if you are given that, all that you need to do in scientific notation is to try to position the decimal point between the 6 and the 0. So you're moving 1, 2, 3, 4. So this number in scientific notation is simply 6.034 times 10 to the power minus 4 times 10 to the power minus 4. We want to convert this into scientific notation. Since there's no digits after the 4, we're aiming to bring the decimal point in front of the 4. So it moves 1, 2, 3, 4, 5, 6, 7. So 4.0 times 10 to the power minus 7. Of course, if you don't want to put the 0, you could have just simply said 4 times 10 to the power minus 7. That is also acceptable. That's correct. And that's also correct. Now we have scientific notation and we are converting that to the decimal form. So remember, you have 1.78 times 10 to the power 3 is the same as divided by 10 to the power minus 3 is the same as 10 to the power 3, which is the same as 1.78 divided by 1000. Now, if I write 1.78, then I'm dividing by 1000, so it moves 1, 2, and 3, and the decimal point will be here. There's nothing, no digits, so 0, no digits, so 0. So the point is now there. But remember, we cannot leave our answer starting with 0.00178. So we have to put a 0 also there. So 0.00178. That's our final answer, which is the same as the one we had there. So again, to write this in decimal form, you got 4.71 times 10 minus 5, which is the same as 4.71 divided by 10 to the power 5. So we are having 4.71 divided by 1, 2, 3, 4, 5 divided by 100,000. So I write my 4.71 and the point moves 1, 2, 3, 4, and 5. And so the point will be here. There's nothing here, I put 0, nothing there, I put 0, nothing here, I put 0, and nothing there, I put 0. So there are 4 zeros that comes there. So my number now is 0.40471. But I have to put a 0 here because I cannot start without that. So this is equal to 0.1234471. Usually when you're writing your final answer, there's no point to still be showing those things there. So that's when you are showing you're working out. But once you're done, you just have to just write what your answer is. Okay. Let's pause the video here, please, and copy this into your maths books and answer them showing you're working out. Again, pause the video, copy this into your maths books, show you're working out. Again, let's pause the video, copy the questions into your maths books, and show you're working out. Remember, all the answers to the questions are at the end of this video, so you'll make your work. Right, let's focus on this question here. Maybe I can do that practice for you to see. We need to apply the index laws to this. So this will become 2 to the power minus 3 because it will distribute, this power will distribute across everything inside here, times 10 minus 3 times minus 3. Be very careful with this. Now, 2 to the power minus 3 is the same as 1 over 2 to the power of 3 times minus 3 times minus 3 will give you positive 9. Positive 9. That's 1 over 8. 2 to the power 3 is 1 over 8 times 10 to the power of 9. Now this is equal to 1 over 8, 0.125 multiplied by 10 to the power of 9. Remember, we have to write these things in scientific notation where necessary. So this will be equal to, I move the decimal point one place, 1.25 times 10 minus 1 times 10 positive 9. This part here is still the 0.125. That's still the 0.125. But this allows me to combine those powers, and so this is 1.25 times 10 to the power of 8. 9 minus 1 is 8. So this is my final answer. That's the final answer for question E. So follow this process and try and do the rest, applying the index laws. Thank you very much. So today's lesson on scientific notation, we're focusing on very small numbers. So all the powers of 10 were negative for those small numbers. Our learning intention was to express decimal form in scientific notation and vice versa. And that was our success criteria as well. Please make sure that you complete all the practice questions in this video in your maths books, showing the required working out. Additional work is set on your online homework Education Perfect. Remember, during remote learning, it's still optional, although I will encourage that students try their hands and do some work. Also, kindly do the checkout at Google Classroom by selecting yes, I've watched the video. That would be great. And please, if you can also subscribe to my YouTube channel, that would be very much appreciated. Thank you very much. So you can receive new videos when I post them. The channel name is Tabi. So please, if you can subscribe, I appreciate that. Thank you very much. And thank you for the lesson. Answers to the practice questions are here. So you can answer those questions, and you can also use this to answer those questions. And if your answers are different, please fix your errors. Just fix your errors. And if you don't understand why you're making those errors, please post your query or questions on Google Classroom and I'll be there to answer them for you. All right, have a lovely day and thank you very much. Yanai, once again, thank you so much. Well done.